all of you have got the question right? Hello?
Yes, sir.
Yeah, I'm just, so I hope you have made out something out of this problem. Hello?
Yes, sir.
So what is the first thing that you will do here?
Write the reactions.
Excellent, excellent. That's a wonderful thing. So you will write the reaction for this. What will you write the reaction? You will write a neutron plus U235, correct?
Yes, sir.
They are the reactants, and the products will be krypton plus barium, right? Plus Q.
Yeah. Yes, sir.
I hope all of you have written this reaction. Excellent. Okay, fine. Now, having written this reaction, okay, so the next thing is you have to account for the energy. Yes, I hope your balancing is it going to involve? Yeah, is it going to involve 35 plus 56? Does it need balancing? So you will balance it and write the equation. That is number one. Next, what you will do? Okay, we'll see what is to be done. Next, what you will do once you have balanced the equations?
Energy.
So you will find out delta M, mass defect.
Yes, sir.
Okay. AMU is given. So you will find out the mass defect in AMU units. Correct? Or in atomic mass units, you will find the mass defect. Right?
Yes.
Okay. And then you will multiply it by 931, the delta M that you get. You remember yesterday I wrote that equation. Delta M will be equal to delta M1 minus delta M2 minus delta M3, that type of equation. Hello?
Yes, sir.
So you will get the mega electron volt in that. Okay? But now they are asking you to convert that mega electron volt into kilovolt. So mega electron volt, if you you have to first convert it into joules. Correct? Hello?
Yes, sir.
So mega electron volt you have to convert to joules, and the joules you have to convert it into kilowatt, and that will be the answer.
Yes, sir.
That will be the answer. Okay? Hello?
Yes.
So, see, now we don't have time to go through all the calculation because I just want to run through this, because anyway you are going to solve quite a number of problems on this in your college, right? So this should give you the direction how to go. That is the main idea of this session. Okay? Yeah. So my dear friends, let us see where we are right and where we are wrong. So here it is 92. Sorry, I think it is 36. Krypton is 36. If it is 36, it will get balanced.
Yes, sir.
Then it is U2 35. So 141 plus 92. So then 3 neutrons out. So sorry, it is not 35. Krypton is 36. So then this will get balanced in one shot. That is the first one. I think all of us have got it right, but unfortunately we took this as 35 and therefore we were struggling to balance. It is actually 36. Got it, friends?
Yes, sir.
As far the mass number is concerned, well, if these two things get balanced, then obviously the mass number will get balanced by the neutrons that is going to give out. Anyway, they have told it is fission reaction, and therefore there must be neutrons that are going to come out. Okay. The next step that we wrote here was perfectly correct. Okay. So here mass of the U235 and mass of the neutron minus the mass of these things, that gives you delta M, and delta M you will directly get it in U, atomic mass units. So this into 931 gives you 200 megavolts. This step was also right. Now this step nobody pointed out, even I did not point it out, because it was 1 gram of uranium. So 1 gram of uranium will contain so many atoms, right? So 1 gram of uranium contains so many atoms. So therefore the energy release, see, this is the mass effect when you have taken each atom. Got it, friends?
Yes, sir.
Now there are so many atoms, 2.56 into 10 to the power of 21 atoms. So you will multiply 200 by 2.56 into 10 to the power of 21. And that gives you 505.12 into 10 to the power of 23 mega electron volts. Okay. So this step all of us forgot. 1 gram calculation heat. Right. And once you have got this mega electron volt, then the next step is to convert it into joules. Okay, friends?
Yes, sir. Yes, sir.
So once you have got this in joules, 8.2 joules. So now you know kilowatt hour, watt hour. Watt hour gives you what? That is watt second is 1 watt is joule per second. Correct? So this is so 1 watt is 1 joule per second. So in 1 hour you will multiply it by 3600. That gives you watt hour. And divide that by, that gives you watt hour. That is 1 joule is 3600. 1 joule per second is 1 watt. Isn't it? Or 1 watt is 1 joule per second. So 1 joule per second you have to convert it into hours. So 3600 you will convert it and divide it by 1000 you will get kilowatt hour. So 3.6 into 10 to the power of 6 joules is equal to 1 kilowatt hour. Hello. So therefore 8.2 into 10 to the power of 10 divided by this gives you 2.28 into 10 to the power of 4 kilowatt hour. Okay?
Yes, sir. Yes, sir.
Now, what did you understand from this problem? What is that? What is that really makes you feel wonderful, very nice? Or what is that abstraction you got from this problem?
That the amount of reactant we take will also matter in how much energy is produced.
Good, very good. So you see, now in your home, if you have got a boiler on which it is written 1 kilowatt hour or 1 kilowatt coil. See, the boiler coil is written as 1 kilowatt. The boiler water heater that you have got in your house. That means if you keep your geyser on, it is written the coil that you are using is 1 kilowatt. Understood? The coil that you are using is 1 kilowatt. And if you are keeping this 1 kilowatt coil on for 1 hour, okay, then the electricity is going to, the electrical company is going to charge this 1 kilowatt hour as 1 unit of electric power.
Yes, sir.
Understood? 1 kilowatt hour. Right? That means if you expend 1 unit of energy, that means you are consuming 1 kilowatt hour of power. So imagine in your home, supposing 4 people take part in 1 hour, right? That means so much of water you are going to heat. Okay? And imagine how much is the power that you have got from 1 gram of uranium? 2.28 into 10 to the power of 4 kilowatt hour. That means, see, now assume that with 1 kilowatt hour you will boil 4 buckets of water. Hello?
Yes.
So with 2 kilowatt hour you will boil 8 buckets of water. Okay?
Yes.
So that means now 8 people can take bath. But you see 1 gram of uranium, 80,000 people can take bath. You understand?
Yes, yes.
Just imagine 1 gram of uranium U-235. Understood? So that is the power of the uranium fuel. Ultimate. Okay, shall we proceed, students, to the next problem?
Yes, sir.
Yeah, so this problem very methodically, if you go through, if you have understood what is this mass effect, and see, everything comes here. Your chemistry also, chemistry that you have studied, you know, Avogadro's number, etc. All those things will come into picture, and then you know all these concepts get connected, and you have got conversion. Everything there is there in this problem, in this numerical, and it's a wonderful numerical. It is not only an exercise, I mean just an exercise of numbers, but it is revealing so much that so much energy is present in just one gram of uranium. All right, friends, shall I proceed?
Yes, sir.
Yes,
sir.
Yes.
Yes.
Go to the next problem. It is proposed to use the nuclear fusion reaction. So this is the fusion reaction in a nuclear reactor of 200 megawatt rating. If the energy from the above reaction is used with 25% efficiency in the reactor, how many grams of deuterium will be needed per day? Mass of this is so, mass of it is so. Now, just understand this problem and tell me what you have understood and how you will proceed to solve this problem. See, please understand that your focus must be on learning. So, aram se learn. There is no hurry. There is no competition to solve the problem here. I want your focus to be on how you understand this problem, how you put it. Put it the way you feel is right, with the due process of science. If it goes well, fine. If it doesn't go well, okay. Where it doesn't go well, just focus on that and learn. That's all you have to do. And keep doing this.
Said that the nuclear reactor is rated 200 megawatts. Sorry, megawatt. So, 200 megawatts of power needs to be consumed, sir.
Consumed?
Sorry, it will generate, sir.
So it will generate so much power. Okay.
Yes, sir.
And then your reactor is using deuterium.
Fusion reactions.
Fusion reaction, they are using deuterium.
Yes, sir.
Right. Then if the above reaction is used with 25% efficiency, that means 200 megawatts.
25% of the energy that is produced in the reaction.
So how much energy is produced?
25 by 100 into 200, sir. 50 megawatts.
25% efficiency means 200 megawatts corresponds to 25%, isn't it?
Sir, but it is rated 200 megawatts. Like in ideal condition, it will give 200 megawatts.
That is not the way to look at it, man. The efficiency of a machine is 25%. Means what? The machine actually generates 100 units, but what is coming out is only 25.
Yes, sir.
That's the way you are going to look. That's the way you are going to look. See, the machine produces so much, but you are able to utilize only 25% of it.
Yes, sir.
Isn't it? So accordingly, it should produce 400 megawatts. Okay.
Sir, but when we say that bulbs are rated to 20 volts, means like they can use that to 20 volts, but even below that we can use.
Listen. Good. Aram se. Bulbs are rated 100 watts.
Yes, sir.
What do you mean? Bulbs are rated 100 watts.
Which means till 100 watts energy they can produce.
Hey, bulb will produce energy,
Lights in the form of light.
Bulb में rating दिया 100 watts का मतलब क्या है? That means it will consume 100 watts of electrical energy.
Yes, sir.
It will consume 100 joules every second.
Yes, sir.
And produce light.
Yes, sir.
Mother?
Sir, but even below that it can be used, sir. It will be dimmer, but it can
hey,
be
used. Delicate na. ಏನೇನಾರು ಮಾತಾಡ್ತಿಲ್ಲ ಡಿಮರ್ ಗಿಮರ್ ಅದೆಲ್ಲ ಯಾಕೆ ಬೇಕಾ ಬರೀ 100 ವಾಟ್ಸ್ ಅಂದ್ರೆ ಏನ್ ತಿಳ್ಕೋ ಅದ್ರ ಕೆಳಗೆ ಆದ್ರೆ ಡಿಮರ್ ಆಗ್ತೈತಿ ವೈ ವಾಂಟ್ ಟು ಶೋ ಸಮ್ ಎಕ್ಸ್ಟ್ರಾ ನಾಲೆಜ್ ದೇರ್ ಶುರು ನೀ ಸುಮ್ಮನೆ ಕಲಿಯೋ ನೀ ಹೇಳ್ದಂಗೆ ಸುಮ್ಮನೆ ಕಲಿ ಅಲ್ಲಿ ಏನೇನ ಮಾತಾಡಕ್ ಹೋಗ್ಬೇಡಂಗೆ ಸೈನ್ಸ್ ಅದ ಏನ್ ಬೇಕಾದ್ರೆ ಹೇಳಕ್ ಆಗುದಿಲ್ಲ 100 ವ್ಯಾಟ್ ಕನ್ಸ್ಯೂಮ್ ಮಾಡ್ತೈತೆ ಅಷ್ಟೇ ಅದು ಈಗ 25% efficiency, that means it is going to produce 800 megawatts, out of it 25% will be available. Okay, now question is how many grams of deuterium will be needed per day? Okay, so the forward problem they had given and they asked you to calculate the energy. You have to do the ulta with the concept of this one. That is the main difference between the two. Rest everything remains same. Correct?
Yes, sir.
Here also you will calculate the mass effect of the reaction mass effect of the reaction you will calculate, multiplied by 931, you will get mega electron volts, and that mega electron volts you will divide it by 1.6 into 10 to the power of minus 19. So you will get it in megajoules. Understand? Megajoules you will get it, and then the joules you have to convert it into kilowatt hour divided by 3.6 into 10 to the power of 10, right? And that one you have to now say for 800, what is the thing that will be used? How many grams? Whatever you did in the previous example, ulta you have to do it here. That's it. I hope you are able to capture it.
Yes, sir. Yes, sir.
So they have calculated Q by calculating this, and well, they got so many electron volts. Megavolts is converted into electron volts. Since it is 25%, 25 by 100 into this. Okay, Mr. Abhinav, got it here?
Yes.
So this into 10 is equal to so many joules. So effective energy that that is necessary, that is used, is so much. Since deuteriums are involved, therefore the energy released per deuterium is so and so. For 200 megawatts per day, the number of deuterium required is so and so.
Yes, sir.
Everybody, aram se have a look at it. So this is giving you number of deuterium used. So number of deuterium used. So you have to convert number of deuterium, and in 2 grams constitute, because deuterium is D2. So 2 grams molecular weight, 2 grams constitute 6.023, 6 into 10 raised to 23 nuclei. Amount of deuterium required is so and so. You see every step. Did you want to follow this? Now don't be hurry in writing it and all. Please appreciate and understand this problem aram se. So step by step, delta M calculated, got electron volt, then total energy that you have to generate multiplied by 4. So in this much energy is generated, right? Out of this energy, 1/4 of the energy is coming out in one reaction. 1/4 the energy is coming out in one reaction. Okay? Then per deuterium, how much energy is generated? This is going to give you. So now this much energy, that is 9.534 into 10 to the power of minus 13 by 2, is the energy generated per deuterium. Okay? And then for 200 megawatts per day. Okay, see this 86,400. What is this 86,400?
Number of seconds in one day.
Yes, number of seconds in one day.
Yes, sir.
So divide by this, gives you this. What I had told you was 200 megawatts into 4. That is the energy that is generated. I had done that calculation before. Right? So here only difference is this is generated so much energy, and out of this 1/4 is used. That is the total energy generated. Efficiency is 25%, means 1/4 of this generated energy is actually the rated power. That is what is written. Okay? Shall I proceed? See, it is 7:30. Half an hour passed. We are just in 2 problems. Shall I proceed, students? Completely understood? Don't worry. See, what is my strategy? I will tell you. Now that I have taken couple of very strong problems, and what are all the concepts, most important concepts that will be used in solving this. I have tried to get all those concepts in the couple of 4 problems that I have taught you. Okay? So in college anyway, when they teach you this, they are going to solve n number of problems. Plus, I will also give you some worksheet, and then you will become perfect. Okay? Now, don't try to become perfect in this chapter in one day. I hope you have understood how to go about doing it. So when the numericals are going to be given in the college, you will be able to tackle those numericals and become more experts. So for that, I have prepared you with whatever limited time that you have given me. Shall I proceed?
Yes, sir.
Yes.